Well, hello everybody, and welcome back. Chapter 9 now, Managing, Coordinating, and Monitoring Resources. So here we go. So the system software is the term we use for the operating system, or we'll call it the OS, right? And other related tools. And we've already done that in this course, system software, just reminding you. So now the OS, or the operating system, is that set of programs that coordinate all activities on the computer. Some of those features are listed on this slide, and we'll continue it in the next. Usually an OS is on the hard drive, but just be aware that they can be run from an optical drive or a USB flash drive or some other external drive. You might have to do that if you have to restore your hard drive. You might want to use one of these external OSs in a different drive. But normally they're on your hard drive. Now we'll talk about this later, but mobile OSs, they're going to reside in something called firmware. And just to remind you, the firmware, which is added at the time that the manufacturer builds the product, is used to run the programs and on a device, and can be thought of as software that allows the hardware to run. So firmware really consists of that ROM chip. We discussed that back when we were talking about ROM, read-only memory. Or firmware also consists not just on a ROM chip, but a flash memory chip that stores these permanent instructions. Now, routers and ports also have firmware. Other examples of firmware, as previously discussed, the BIOS found in the IBM compatible personal computer, code inside a printer will have firmware, right? In addition to the printer driver that is on the computer. Software controlling a heart defibrillator, I think I mentioned before. Even software controlling lights in an office building would largely be done by firmware. Oh, there was the slide. There we go. Okay, now be aware then that servers, oops, and I meant to, let's go, there we go. I think I'm back to caught up now. Servers do not run the same OS as tablets and desktops because these computers perform different computing tasks. So this also note that the same types of computers, such as laptops, may even run different OSs, right? So when purchasing a program or an application, you really want to be careful. You want to ensure that whatever you're buying works with the OS that you've purchased. Now, one final note, the operating system of a computer, it uses, is sometimes called a platform, right? So the OS, sometimes you'll hear people refer to it as the platform because it runs on top of it and it supports the other applications. So that's really what's going on there. Now, the desktop graphical user interface, or we call it a GUI interface, it shows the configuration of the add-on devices. It gives you, it'll have auto updates of the OS and file management. Some of the things that an OS does for you are represented here. Again, the GUI is in the top right. Some of the other pictures include configuration. We have the file management in the bottom left, and auto updates in the top left. These are some of the things the OS picture-wise will do for you that were covered in the last couple of slides. So now you press the power button and the power supply turns on your computer. Once the system receives a power good signal from the power supply, then the CPU will seek instructions from the BIOS. Remember, BIOS is the basic input-output system, right? And the BIOS, we just said, was firmware, right? I mentioned that on slide 2. And so the CPU is going to seek instructions from the BIOS about initializing the system, and the BIOS will start interfacing with the hardware. Now, when the first program that the computer runs, when the power is turned on, right, it'll start install then the operating system. That'll start working. And it ensures the coordination of the other stored programs with systems hardware components. Now, to enable the operating system to process, a process is done which is called booting. So we sometimes refer to it as booting up the computer. And this involves a series of tests. As it boots up, it's going to test the buses, the system clock, the adapter cards, the RAM chips, the mouse, the keyboard, the drives, etc., etc. And then the kernel becomes part of it. The kernel is very important. If the tests are successful in this boot up process, then the kernel, the OS, is loads from the computer to the RAM. Now, the kernel is the core of the operating system, and it manages the memory and the devices. It maintains the internal clock. It runs the programs, and it assigns resources. The kernel memory is called resident, meaning that it remains in memory while the computer is running. Now, the other parts of the operating system can be non-resident, which means that those instructions remain in storage somewhere until it's needed. All right, so it might remain on the hard drive until it's called forward by the RAM for operation. Final couple of thoughts. The OS in the operating system that's in RAM, it takes control of the computer and verifies then that you're the person that should be running the computer. So when we boot up a computer at work, a lot of times we don't really interact with it until it asks for a username and password, login credentials, right? This is what the OS is doing next. It's asking you to verify that it's you with the username and password. And so, and then a final thought, when you reboot, that really means restarting your computer. So sometimes you have to do this when maybe you add a new program, or you want to update software, or you may even have connectivity problems. Now moving to operating system functions. So we can shut down a computer every day for various reasons. I generally don't. I generally leave mine running, but that does create a small security hazard for me, and it uses some energy. If I shut it down every day, I improve security, I can reduce energy costs, and frankly, maybe even clear my memory out, which is nice. So be aware also that there's sleep mode. Sleep mode stores the documents and files you are operating in RAM. It stores them, and it uses a small amount of power in the process. Hibernate mode essentially does the same thing, but this is actually going to save the information to your hard disk, which allows your computer to be turned off completely and use no energy, which is nice. An example of hardware device is with the user interface, that is remote control, right? Remote control is a user interface, isn't it? When we sit in front of our TV. Well, we interact with the OSs through a user interface. So most of the users today use the GUI, again, or graphical user interface. So that consists, we saw, of the picture-like items, right? Icons and arrows, for example. The main pieces of a GUI are the pointer, the icons, the windows, the menus, the scroll bars, etc., right? So some common GUIs are the ones associated with Windows that are common to us, maybe Mac OS X, Chrome OS, Android, and others, right? Now a GUI is sometimes called a touch user interface if it's designed as touch input, like a touch screen. So sometimes you'll hear the GUI called a touch user interface, same thing. Now there is an NIU, that's a natural user interface. The goal of an NIU is to create this seamless interaction between the human and the machine, making the interface itself seem to disappear, right? So we want to the experience to be ordinary, intuitive behavior, right? Touch screens give us a little bit of that. When we do gesture recognition, that's a way to do it. And I put a link here to YouTube to the movie Iron Man, and he's doing the gestures in front of his computer. You're welcome to type that in and review it. It's interesting, but it's showing you this natural user interface live. Other forms of natural user interface include speech and virtual reality, like simulators. They provide this. And simulators, by doing this, they actually accelerate the experience, right? And this is really what Iron Man does in his movie. So very interesting. Now, these are some of the pictures of GUIs. Good user interface design can actually make the product easy to understand and use. And this results in greater user acceptance. That's really what we want. That gets market share. So the term user interface refers to the methods and devices that are used to accommodate the interaction we've been talking about between us and the machines who are using them. It's a critical piece. Now, network administrators work and manage these operating systems often through a command line interface, right? So outside of GUI, which is nice for us, administrators instead use a command line interface. In the command line interface, the user types in commands such as dir, D-I-R, right? And that command is used to view a directory or list of files. And the command line interface requires exact spelling, form, and punctuation, right? So you see on this slide, the computer displays a prompt, and the user or the administrator keys in the command and presses enter or return, right? In the early days of computing, or at least with using personal computers, all PCs used command line interfaces. It was GUI's graphical user interface that came about later. Now, in OS operating system functions, this is very interesting. So I'm going to pause here and come back and start here in part 2 of this week's discussion.